we are going to discuss a small problem on center of gravity and moment of inertia. This is second problem. Myself, P Patil, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Dear friends, in today's session, we are learning following two terms. That is, first one, you may identify the center of gravity, and the second part is the moment of inertia. Let's we begin with the problem. Find the moment of inertia of shaded portion. Shaded portion is nothing but the hatch portion is there. So find out the moment of inertia for a shaded portion about its AA axis. About its AA axis. So first of all, you may observe the figure. This is the schematic diagram. So one semicircle is there, and this is nothing but the shaded portion. So the dimensions they have given, that is this is 300 mm total, and you may observe this is 700, and here the axis they are given, that is nothing but AA axis is there, and this distance is 250 mm. So the total dimensions they have mentioned. Now another one dimension is remain, that is nothing but the radius of this particular semicircle. So it is 150 mm is there, 150 mm. Now the steps are finalized. First step, you may calculate the area. Second step, you may consider the reference axis. Third step, you may consider the centroidal distances. Then find out the centroid. Then find out the moment of inertia. But see, here in this particular problem, specifically they have mentioned you may identify the moment of inertia about AA axis. There is no need to calculate the x bar and y bar. Please take care. If they have mentioned about the centroidal axis, so it's your task, you may identify the moment of inertia or the centroid about the given axis, that is xx yy. Here they have mentioned AA, so along with AA axis you may identify. Now this AA axis is parallel to the y, so you may utilize the formulas for IYY, that is for y axis whatever the formulas are there, that particular formulas you may consider it. Let's see, observe. First of all, I am considering this is the small g1, this is my figure number 1, and this is the small g2, this is my figure number 2 is there. Why it is essential? To identify the distances. Second part is present here, that is you may calculate the area. So area of figure number 1, that is a rectangle. Area of figure number 1, A1 rectangle, B into D is there. So you may observe B into D, that is nothing but the width is 700 and the depth is 300. So 700 into 300, you will get, that is 210 into 10 power 3 mm square. Simultaneously, you may identify the area for second figure, that is nothing but this for semicircle. So area of second figure A2 is equal to, now area of semicircle, that is pi r square by 2 is there. Okay, so now you may observe pi into r, this is 150, so 150 square divided by 2, so you'll get the area of semicircle, that is near about 35.34 into 10 power 3 mm square, 35.34 34 into 10 power 3 mm square. This is regarding your area. Now directly, because there is no need to calculate the centroids, that is x bar and y bar, directly with respect to given axis, that is AA, you may identify the moment of inertia. So to identify the moment of inertia, we need to apply the parallel or perpendicular axis theorem for that, because the y-axis for first one figure, the y-axis for second one figure, and the main axis, that is A, which is parallel to each other, means you may or you may consider the distances between the original axis and the given axis. So the parallel axis theorem we are going to apply. Let's see, observe how to calculate the moment of inertia. So moment of inertia of a shaded portion, that is you may consider about IAA axis, is equal to moment of inertia of rectangle minus moment of inertia of semicircle. Now the moment of inertia of rectangle, that is R, you may consider now IYY1 is equal to IYY1 is equal to, so the formula of IYY along with y-axis, that is dB cube by 12 dB cube by 12 plus the product is there A1 H1 square. What is the formula for semicircle? So the moment of inertia of semicircle, that is IYY2 is equal to, very simple formula is there, that is pi d raised to 4 upon 128 plus A2 H2 square. Now we know the value, that is depth D is 300, your width, that is B 700, divided by 12 plus area of figure number 1 already you have calculated 210 into 10 power 3 mm raised to. Similarly pi, you know the diameter, this is the radius 150, diameter is 300, so pi into 300 raised to power 4 divided by 128 plus A2, area 35.34 into 10 power 3 mm square. H2 and H1 is unknown. How to calculate the H1 and H2? That H1 you may identify, so 700 divided by 2, that is nothing but, this is nothing but your H1. So 700 divided by 2, you will get, this is this particular value plus 250 is there. So let's see, observe, H1 is equal to 700 divided by 2 plus 250, and you will get this particular value 600 mm. Simultaneously you may calculate H2. H2 is nothing but this total distance. How to calculate it now? So total distance, how much it is? 700 plus 250. 700 plus 250 is that. So H2 is equal to 700 plus 250, means you will get the total distance minus radius of this particular semicircle. So minus 150, you will get here, it's near about, do the calculation, you will get 800 mm. Now H1 is known, H2 is known, you may put the values in the formula. So you may observe, we are putting the values in a formula and try to identify the answers. So let's you observe. First one, IYY1, how to calculate it? So dB cube, D is now 300 into 700 cube divided by 12 plus area figure number 1 210 into 10 power 3 into H1. Now h1 is 600, so 600 square. Do the calculation, take a time and try to identify the moment of inertia of a rectangle. So you'll get it's near about 8.417 into 10 power 10, and the unit is mm raised to 4. Simultaneously, we are calculating now the moment of inertia for semicircle, that is Iyy2 is equal to pi d raised to 4. Now pi diameter is 300 raised to 4 divided by 128 plus area of second figure, that is A2 H2 square. A2 is already we have calculated 35.34 into 10 power 3. So 34.34 into 10 power 3 into your H2, that is 800 square. So here also you may do the calculation, try to identify it. After calculating, you will get the moment of inertia of semicircle, and this particular value is 2.281 into 10 power 10 mm raised to 4. But I don't want the moment of inertia of semicircle and the rectangle. I want the moment of inertia for shaded portion. So how to calculate it? Moment of inertia of a shaded portion is equal to moment of inertia of rectangle minus moment of inertia of semicircle. So already we have calculated the moment of inertia of rectangle is 8.417 into 10 power 10 minus moment of inertia of semicircle, that is 2.281 into 10 power 10. So we'll get the moment of inertia of a shaded portion, that is 6.135 into 10 power 10, that is mm raised to 4. This is the moment of inertia about AA axis, that is nothing but the shaded portion at AA axis. So to prepare this particular video, I have referred, these are the references. Thank you.